Today, we are going to discuss what we can call climate disruption. Climate disruption is sweeping change in the climate, chaotic change. It is not simply global warming, it is something much more than that. After studying so many issues and books, I have come to the conclusion which I would like to say in the beginning itself, that this is an existential crisis. I came to the conclusion that human beings, that is, the species called sapiens, is not likely to survive. It's very sad to know. More than hundreds or maximum thousands of years. I am not talking about what happens by 2100 or by 2050. Okay. So many people talk about 2100 as if 2100 is the end of the universe. It is not about 2100 and 100. It is about what is it after that. Consider some hundreds or thousands. If you consider, it doesn't seem that sapiens is going to survive. I have seen scientists' reports. Scientists give some numbers and then they also say we can change if we try, but politicians are not changing. Without going into their talk, which is optimistic, or they're simply saying like that, if you go only by their numbers and what they think are the consequences of these numbers, and if you apply your understanding of political and economic situation, that is the sweeping changes that are required to undo the climate disruption, and if we think whether the economic and political systems that we have are capable of bringing that change, if you consider all these factors, to me it is clear that sapiens are doomed. Unless there is probably one technological miracle. Unless a technological miracle there is, I don't see any political and economic change that can undo this. Why did I come to this conclusion? I'm just going by the numbers and the process, not the optimistic talk of certain activists or what scientists themselves might say how it can be undone. Okay. They say, first of all, 2C is catastrophic. 2C catastrophic. 2C rise refers to pre-industrial level, all these CO2 concentrations on this scale started after industrialization. So they take the reference of pre-industrial level and what is the likely warming. Scientists say that above 2C is catastrophic. That is one number. We're just going by the numbers. They say it's catastrophic. But do you know, as of now, we have 1.1C. As of now. As of now, it's 1.1C. And then, there are certain very important points here. This 1.1C is as measured now. As measured now. As measured now doesn't take into consideration the equilibrium temperature. See, there is a lag between temperature and heat. Heat doesn't immediately contribute to temperature rise. Take ice, you give a lot of heat for it to become water, but same temperature. And then for water to rise its temperature, much more heat. This is what is called ocean thermal lag. There's a lot of heat is going into the oceans, not contributing to immediate temperature rise. And estimate of this kind of possible temperature rise, which the scientists say locked in temperature. They also say committed temperature. As of now, which is in the oceans, is 0.6. 1.6. 1.6 is already locked because of 1.1. And then, if you are not going by 2100, and if you see what will eventually mean, given the CO2 now, CO2 will stay for hundreds of years. Estimates vary from 300 years to plus. So if you take eventual rise, they are saying that is 2C rise, which means this is already 3.7C. 3.7C is the equilibrium rise, which we are bound to rise. Okay. Because I am not talking about 2100, I am talking about eventually what happens. So, the present rise or the temperature itself is not a very good indicator. Scientists say better indicator is CO2 levels, which are measured in terms of ppm. So ppm will give eventually what is going to be the rise. So that's one. And what is the effort that we are putting in? There is Paris Agreement signed in 2015. See, one thing about Paris Agreement which not everyone understands is that Paris Agreement signed in 2015 says that we will try to be below 2C, we will limit below 2C, but we will try to limit below 1.5C. We will try for this, but we will do this. But you know, this 2 and 1.5C is only a talk. 2 and 1.5C is only a talk. What is important is not what the politicians talk. What is important is at least what the politicians have pledged. And it is here you have nationally determined contributions. Each country gave an assurance that it would end disease. Scientists are saying if NDCs are implemented, what will be the rise? So the point is, if NDCs are implemented, we know that normally they are not implemented. For example, US is out. Many are not up to what they promised. Okay. But assuming NDCs are implemented, here I am quoting one report very recently released in Australia, that is Dunlop and Spratt. And they take studies, they take many studies, but one is Gu and Ramanathan. They released a report on what would be the scenario on the basis of Paris Agreement. Assuming NDCs are implemented, okay, the figures that they are giving are shocking. The report says by 2030, we will reach 437 ppm by 2030, and correspondingly the rise is going to be 1.6 C. They are making use of this data. This report gives the connection between ppm and Celsius rise. So they are saying by 2030 it is going to be 1.6. Already it is 1.1. And then by 2050, 2.4 C. And by 2100, 5 C. 5 C. How is this report different? This report, the authors say, take into consideration what are called positive feedbacks. Positive feedbacks are about when something happens, something else happens. One very important thing is about Antarctica. Arctic. Most scientists think that Arctic is going to play a very, very important role in this. That is the most happening place as far as global warming is concerned. Why is it important? Number one, there is a lot of ice which is reflecting the radiation, which is called albedo effect. And when ice melts, the albedo effect is gone, and moreover, it is replaced by black ocean, which takes more heat. So, albedo effect gone, more warming. takes place. And of course, this melting rises sea level. That's another. But there is one very dangerous thing here. Below this ice sheet, there are gases, methane, carbon dioxide. Life was there at that time, at one time. So much of carbon and methane was there underground. And estimates say that if all that is going to be released, it is going to be, the CO2 equivalent is going to be more than twice the CO2 what is already there in the atmosphere now. 2 times. They are thinking in terms of, others are thinking in terms of the tipping points. At what sea this entire Arctic will melt. And then after Arctic melting and at some other level, some other higher temperature, Antarctic will have a problem. What are considered stable in Antarctica are also showing changes. So tipping points seem to be varying. Tipping points contribute to positive feedbacks and run what is called hothouse effect. Earth is going to be very hot, and so those tipping points, feedback systems are considered. This will, and moreover, what are effectively working as carbon sinks now, like oceans, they will not be so effective carbon sinks after absorption of particular level of CO2. That is another issue. Because water content is changing in the oceans. Water content is changing because of higher temperature, ocean heat, acidification and loss of oxygen, and all these things contributing to coral reef destruction and species loss. But all these also change to what extent the oceans are going to be sinks. So all these systems considered, they think it is going to be 5 sea rise, which leads to, according to them, 2-meter rise in ocean level, and then 2-meter ocean level rise by 2100. Others say eventually, going by prehistoric period, it is going to be 25-meter ocean rise. That is what it is going to be. So this is the most recent report, and if you think scientists are alarming, that doesn't seem to be the case, because going by evidence, if you compare what happened versus what the scientists want, what happened is more dangerous, more serious than what the scientists predicted. Scientific reports have been underestimated. This is another issue. IPCC reports, which are based on consensus, many say, are underestimating and underreporting the severity of the threat. That is the way they are reporting. They basically take various reports and then come to a consensus, and they want to be very, very accurate. They don't want to sound alarming, and in the end, most reports say they are very conservative. In fact, one report, IPCC 1.5C report, which is considered much better than others, predicted Um, we'll look into that. See, 1.5 is going to be now when, I mean, it predicted that when that 1.5 will be coming, that it predicted around 2040 plus, but then it is coming out to be around 2030. So 2018 report itself is not able to predict how soon that 1.5 mark will be reached. So it's usually under reporting. Okay. See, one way to understand how serious and significant these changes are is to compare when things like this ever happened. And when scientists are looking at when things like this ever happened, they happened millions of years ago. So they compare the present with something millions of years ago. So the change now is extremely different and radical. Take for example figures like this. You have studies of ppm, that's about parts per million. CO2 is measured in terms of parts per million. And now parts per million, we reached 410 plus. In December it was 411.85. December 2019. 411.85 December 2019. Okay. And do you know, in the last 800,000 years, ppm did not cross 300 at all. It was less than 290 to some plus. It is less than this. So 300 crossing took place recently. And when was it like this at 400? They are saying it is around 3 million years ago. 3 million years ago. 3 million years ago. So the present ppm was around 3 million years ago. And you know what was going on around that 3 million years ago? There was no Homo sapiens. There was Homo habilis. Homo habilis. Evolving around that time. Sapiens came only around 4 lakh years ago. Sapiens came only around 4 lakh years ago. So the changes that we are seeing going by 400 ppm took place around 3 million years ago. It means sapiens as a species is not subjected to this climate at all. So very important changes. And what sapiens depend on, take for example agriculture, all these agricultural developments took place in 10,000 plus years. So all the agricultural developments, plants and everything worked on the climate stability after 10,000 plus years. So this is a change of a different scale altogether. It's very difficult for us to imagine what it is like. And if this is the change, remember, this is not final. Things are going to be much, much different, worse. And it is not only the change, but also pace of change is important. If you want to see the pace of change, and at one time what is called PETM, Paleocene Eocene temperature maximum period. It is during PETM around 55 million years ago. Something like this in terms of rapidity of the change took place. And even then, the change now is 10 times more than the change during PETM. Okay. But how can we measure all these changes simply in terms of ppm and temperature? Ppm is related to temperature, and temperature is related to so many other variables. The entire climate systems move. Climate systems movement has been there all along. ppms rise, fall, and when warming takes place, the entire life system moves from equator to the poles. Some people think, okay, after all, people near the poles or colder regions will be benefited, and it is all a problem with the people equatorial. They are so completely wrong. This change is at such a level that it is true, life system may move. That is the way nature works. But that life system that is going to be near the poles or near the north and south poles is not going to be sapiens. That is the point. Some other life system may come after many millions of years. Why millions of years? Because of the sweeping change, very few species will be able to adapt. So most of them are going to die, which is called the phase of mass extinctions. 5 mass extinctions took place already in the history of the earth, and this is likely to be the 6th mass extinction. Mass extinction takes place when the change is too rapid and species cannot adapt. And sapiens also can't adapt. But sapiens adaptation process is through brain, through cultural process, through elaborate use of technology. So, but when everything changes, and but even human adaptation is around 35C. But after that, for all likelihood, if sapiens survive, there may be like few thousands near the poles, the way Neanderthals lived long ago. I don't see how future is going to be different, because there is a rapid change, and probably after mass extinctions, and some species will start the story of evolution of new life. Sapiens came to be dominant after the mass extinction of dinos 65 million years ago. And when dinos were ruling, ancestors of sapiens were very small, something like squirrel size. And then things happened, and finally sapiens came around lakhs of years ago. So sometimes scientists think that if this mass extinction happens, some other species which is maybe as small as a rat or rats themselves may evolve and may become dominant species later. So it is not that the climate systems move and it will be advantageous to some humans. It is not going to be like that. It is going to be advantageous to some life forms in very, very, very distant future. So this is the time scale and too rapid change. So this is what the scientists are saying. And we keep hearing, we keep meeting, we discuss all kinds of things. But what matters is not what we discuss and what we promise to do, but what we are actually doing. And if you go by what we are actually doing, if you take the latest report, 2018 report, everything, CO2 increasing, CH4 increasing, N2O increasing, all three are increasing. There is no letdown at all. And then forest loss is taking place. Amazon forest loss is taking place. Deforestation is taking place. CO2 emissions are. Alright. Only change is that, positive change is that, fossil fuel, these gases are released because of fossil fuels of coal, oil and gas. And only change is that there is some decline in coal consumption and increase in wind and solar. This is the only change. Net emissions are increasing. Decline in coal substituted by wind and solar. After all these years of talk on global warming, this is the change. But again, what is important is not this change. Finally, its impact in terms of ppm. ppm is shooting up. 1990 to 2000, there is a rise of 1.5 ppm per year. 1990 to 2000. And then next 2000 to 2010, 2 ppm rise per year. I think this is a very, very important measure. It means there is an increase in growth itself, and now it is 2.5 plus. If you take most recent increase. So it is not what we talk, it is about finally what is its impact on the ppm. There is no letdown, it's rising. So where is the future? And 1.5C report of IPCC says that you can have 1.5 if 45% cut by 2030 and 0 by 2050. 45% cut by 2030 from 2010 basis and 0 by 2050. And then strangely they say that it will happen so, it will limit to 1.5 C, but the probability is only 50% chance. 2 points, 3 points. 45% cut by 2030, 0 by 2050, and then it is 50% chance. We are nowhere near. And it's peaking, it need not, this peaking need not be reached at 2030, it can even go up 2050. Because we know very clearly that politicians promise and promise with a very, very confidence that they need not implement. There is no global government which will force governments to do these things. There are simple measures. First of all, going by carbon tax. Countries continue to subsidize coal, subsidize oil and gas. They continue to expand these fossil fuels with some progress in renewables. So, I don't see any drastic change in the behavior of the governments or the people. And things like this, which call for sweeping changes in urbanization, agriculture, transport, the way we live, consumption patterns, it's so sweeping and so radical. It is impossible that our political and economic systems will cooperate to bring this change. It is. We will try to reduce coal, we will try to increase renewables. I don't think it is going to be more than that, and what we do doesn't make much difference. It simply postpones the problem by few more years. And if you are not thinking in terms of 2100, this 2100 is itself is a ridiculous figure. Why people think of 2100? So, if you are thinking in terms of hundreds, because after all we came 4 lakh years ago, and it is reasonable to think in terms of hundreds and thousands. And if you think in terms of hundreds and thousands, it's so hopeless. I don't know what else can be the conclusion, and definitely I would love to be wrong so fundamentally. Okay. So, one difficulty in understanding climate disruption is that we don't think in terms of hundreds and thousands and millions. We don't think in terms of thousands and millions. But things are happening at a different level, and we don't think in terms of species. So we think of, as a nation, maximum as a word, but maximum we think in terms of decades. But this is of a different problem, it's of a different nature, it is beyond the human imagination. So probably this is the only species that dominated the world so comprehensively, probably it is the only species that is monitoring its own extinction, giving monthly reports, daily reports, watching its own extinction. Okay. It's really a tragedy that sapiens have understood things, but they are not in a position to prevent. I want you to think about these numbers and the issues.